Right, so welcome everyone. We're going to be showing you today what happens when you put a domain controller in AWS and how that can go wrong. But before we get started, who are these two strange individuals standing in front of you? Well, this is Leo. He's a senior security consultant and he's the head of our attack path mapping service. He's given a bunch of talks before at places like DistrictCon, DeathCon, and he's here wearing a funny hat at Adversary Village. Because he does attack path mapping stuff, he has to come up with a bunch of crazy PowerPoint diagrams, which we're going to be showing you a few of.
Yeah, it gets pretty intense. And this is James, our interim Purple team lead, also a security consultant. Spoken at many conferences, fuzzer of all the things. You'll see him here speaking at Disobey in Finland. And we're both working for a company called WithSecure Consulting, and we're based in Manchester, UK. So, attack path mapping. Similar to the stuff we've been talking these days, but kind of different. What is this thing? You know, James mentioned that a little bit mentioned that before. Looks a bit like this. Yeah, I'll let you have a gander at it. It's kind of an offensive security exercise that we do. We set out our exercise objectives on the right-hand side, and we also decide our starting points on the left-hand side. And then we try to find all the possible ways that an attacker can take to get there, from point A to point B. And this is a technical exercise. It's hands-on. It's not paper-based. It used to be blanked out as a service, but it's evolved heavily, as you'll see. So as you can probably tell from all the overlays, the colored overlays, to get there, we need to cross various environments on our way. So we'll go through AWS attacks over there with the orange. You get some AD attacks, of course, that's the green. Some Entra ID attacks close to the end, that's the blue one, and even Okta, TTPs along the way. So as you can probably tell, the estates that we see in these exercises are quite complex. But there's one particular combination of platforms that we keep seeing again and again and again, and that's Active Directory on AWS. Effectively, that means lifting and shifting your entire infrastructure, which was traditionally structured using AD, onto AWS as EC2 instances. And that means servers, databases, and even domain controllers, even DCs. Now, you might be wondering why would someone want to do it? Some of the answers we've heard have been cost-related. The whole OPEX versus CAPEX debate could be part of a long-term strategy to migrate to the cloud, or simply they have some legacy applications that they want to support once they've migrated to the cloud. So yeah, we need to bring that AD plane there as well. But the thing is, this coexistence of these two identity planes leads to a very, very interesting situation. And this is mostly what we'll be talking about today. It's going to be mostly a tale of attack paths that are introduced by this coexistence. And then we'll reflect on defensive strategies, both to mitigate and to detect these attack paths. But before all that, James will give you some necessary background and disclaimers. And sorry, we don't have any demos today, but we do have plenty of little attack path diagrams like this one to keep it very structured. So if you fall asleep, it is the first talk after lunch after all. You'll know when to get back on and follow along. You know how much you've missed.
All right, yeah. So we're going to be showing a bunch of anonymized examples of real attacks we've performed on engagements. Something we thought we'd just mention is that we're not really dropping any 0 days or new vulnerabilities that we've discovered ourselves. We're building on other people's work, and we've tried to reference that wherever possible. So we're using existing techniques, but combining them together in interesting ways across both the Active Directory landscape and the AWS landscape. We're also only going to be looking at AWS in terms of cloud providers. We'll talk a bit at the end as to why you don't see this on Azure, and why this talk is about AWS. And the last thing to mention is that when we perform these engagements, they're not really covert. So we're not really going to be talking that much about stealth, and we're not going to be talking that much about reconnaissance. So when we perform these engagements, we're typically asked for a read-only role to map out the environment so we can see all these paths out in the open. So if you ever wonder, but how did you know that role had that privilege? Well, we asked for permission to see which roles had which privileges. So most of you in this room will probably be very familiar with kind of Active Directory tradecraft, but you might be a little less familiar with the AWS side of things. So we'll just go through some basics before we get started. So in AWS, identities are called IAM principals. They're split into two types. Users, which are the kind of more legacy form. They have long-term access keys, and we generally discourage against them now. Roles, these are often associated with kind of temporary access, and they're much more widely used. Both of these have a very fine-grained RBAC model. So you can say that, this role can do this specific action against this specific resource with these constraints. However, people tend to really overprivilege these, leading to a lot of the attacks we're going to show you. So they say you can do this against all computers, which bad things happen. In terms of how you can actually acquire these roles as an attacker or in legitimate scenarios, humans are often provided access via an identity provider. So we'll show an example with Okta later. So you go to a dashboard, you click a button, and you get the role. You can also attach IAM roles to virtual machines. This is called an instance profile, and it means anyone who can execute code on that virtual machine can acquire the keys to that role. And finally, roles can assume other roles, as you'll see there. So if I define a trust relationship from role B to role A, and I as an attacker control role A, I can acquire a set of keys and impersonate role B. And we'll show how that can be used for a bit of lateral movement in Privesk later. So onto the actual attack paths. So we're going to show 6 attack paths here. 4 of them are going to take us from an AWS perspective into a kind of AD perspective, some of them even getting us domain admin privileges along the way, and then 2 of them are going to show the other way around. So if we have Active Directory foothold, how can we go and get potentially cloud admin in AWS?
So without further ado, let's get into the attack paths. First one we have today, I like to call it domain controller snapshot takeover. Bit revealing, we'll see what that means. So let's assume you start from a server. That could be of any operating system. For example, it could be a Unix server, could be a publicly facing web server. Let's assume that. So from your reconnaissance, you figure out that there's an AD domain somewhere, but you're not on it. So you're not running on a domain context. However, that server you've compromised is an AWS EC2 instance. So maybe you get a reasonable assumption that the DC could also be an EC2 instance. So the question becomes, how do you get into the domain to compromise the identity plane? And ideally, how do you get the A, right? Now, since this is an EC2 instance that you've compromised, the first thing you can do is reach out to the instance metadata service, IMDS, and see if there's an IAM role assigned to that instance, which you can then, which is something you can do with just a curl request. With another curl request, you can get the credentials for that role. In that example, it's a role called RHL web server role. So in practice, this is our starting point. This is the AWS credentials, which you could have acquired somehow differently. Maybe find a TXT file or something. These credentials, you can then exfiltrate and configure your CLI, your AWS CLI, which you can then, and then run a confirmation command, the STS get caller identity, at which point you'll have a foothold into the AWS account. And here's an OPSEC tip, you probably know that already. If the AWS CLI is already installed on web server, on that web server, then you can skip these 2 steps altogether and execute from the host directly to avoid that detection opportunity when exfiltrating these credentials. But anyway, I'm digressing. So you've compromised that web server role, but that role will most likely be weak. You would probably need to elevate your AWS privileges somehow. One way that we actually used in that particular engagement is by exploiting the role assumption relationships. If you remember from James's slide previously, roles can assume other roles if the trust policies allow so, and even cross account boundaries. And there are tools available to discover these relationships at scale. Daniel Heisen's ApeMan is one of them, and IAM Graph, developed by our colleague Alexi Kallio, is a similar one. So what we need to do with any of these tools is to find paths that will take us from our role to a more privileged one. And ideally, we want our target role to have EC2 permissions. Hold that thought. We'll see in a second why. Now, both of these tools are graph-based, so you can run some Cypher queries to find that out, find out these relationships. Once we find our target, we can go ahead and assume it with AWS STS assume role command, which gives you the temporary credentials. Now, following the same process again, you can get these credentials into your CLI config, and you've hopped into the allow EC2 role. So if that new role does indeed have EC2 permissions, things get interesting. Now, remember, the DC could also be an EC2 instance. And what we've seen multiple times is that DC EC2s are actually located in the same AWS account as the box that you've compromised, web servers. Why is that? We see that pattern of shared services, which is part of the recommendation. And when we discussed that with the client, they said that this was all, migration guidance, put it all in an AWS account, all these shared services. We'll talk a little bit about that later, about all the mitigation advice and migration advice. For now, we know that the domain's database, NTDS, sits on the DC disk, of course, which in AWS, hard drives are EBS volumes. So what we're going to do is what we call a snapshot takeover. It's a well-known technique. Probably first time it was mentioned was probably 2019, Ben Morris's DEF CON talk. And that consists of basically 3 steps. First, you create a snapshot of that disk once you identify it, which, by the way, might already exist. Sometimes we've seen that the organization is keen to do some backups and periodic snapshotting of all the disks. So that snapshot might already be there. So step number 1, you can possibly skip that. Second step is to create a clone volume out of that snapshot. And finally, you attach that clone volume into the box you control, into the EC2 that you've compromised. And at that point, you have your drive holding NTDS attached to your host. From that foothold, you can then proceed to mount that disk and use maybe something like in-packet secrets dump, pointing it to the NTDS and dump all the domain credentials, including DA, including the domain admins one. And that's about it. You probably got DA. So to summarize that first initial attack path, we saw that if we can elevate our privileges, our AWS privileges, to a role with EC2 permissions, and the DC is reachable by these permissions and the necessary policies, then we can get DA by creating and taking over a snapshot. Cool, attack path number 2. Let's look at another one, quite similar. We have the similar starting point, but the conditions are slightly different. Now, let's assume we also start with broad EC2 permissions, just like before. This time we're targeting a server, and you realize from your reconnaissance that that target server doesn't enforce SMB signing. Big hint, big hint. I know what you guys are thinking already. And you've also found, maybe from your reconnaissance, that there's another computer who has admin rights to that target server. So putting A and B together, our mind goes to NTLM relaying. Okay, how can we possibly trigger a coercion attack with something like petit potam to get that elevated foothold and compromise a target server? But there are some restrictions. There are some network restrictions, like maybe strict firewalling, or maybe the target server is on a different VPC altogether. So our goal here is how to perform that NTLM relay attack to eventually compromise target server. Now remember, because we have EC2 permissions, we can literally change the firewall setup of those systems. We can do that by modifying the security groups to allow SMB to reach target server, SMB traffic, or we can even create a new service, a new security group that includes that particular rule about SMB and enable that traffic to flow. To bridge that gap between the different VPCs, you can also create a rogue instance that will serve as your listener. To do so, you'll need to first create a key pair, as you're going to need to authenticate into that instance. That instance, you're going to have root and administrator on, which will allow you to listen on a low port like 445. And there's a side benefit through that process, I guess, depending on how you see it, maybe a detection opportunity, that it bypasses all the provisioning processes that the organization might have. If you've heard something called like a golden image standard, then you're bypassing that, which means you can deploy any OS you want and skip the installation of the AV, the EDR, any monitoring software that's in there. And a final step would be for that rogue instance, create the necessary security groups to allow inbound and outbound SMB traffic to flow. With all these conditions in place, the next step is to start the coercion attack, execute petit potam, and then having started your relay on your rogue instance, you can catch the authentication, relay it, and by default, dump the sum, get the hashes, and you've compromised that host. Now, what we saw here is yet another basic Active Directory attack. You've probably seen it already, NTLM relay. But because we have these AWS permissions, we can break the assumptions about the firewalling. And I remember yesterday at least 2 talks that recommended firewalling outbound port 445. It was Lee Christensen's NTLM one and I think the Chris Thompson's SCCM one. So the common theme there was, consider blocking outbound SMB. But we'll show you here a way to bypass that. If you do have these AWS permissions, you can bypass these firewalling restrictions.
All right, so now we're going to take a look at another way of kind of getting a code execution foothold on EC2 instances. So again, we're going to start off from the point of view of an IAM role, and the IAM role that we're going to start off with is going to be one that has access to the SSM service. The SSM service is responsible for systems management. So we commonly see this kind of attached to roles that perform VM maintenance, patch checking, vuln scanning, that kind of thing. That's where this role goes. And we'll just show you how this can, just get a simple foothold and actually the implications it can have in the domain environment. So SSM has a really nice action for us as an attacker, literally called start session. And this means we get an interactive shell on the EC2. There are a couple of preconditions, but one of the interesting things about this is that we don't need direct network line of sight to the target. So we're going through the AWS APIs. And so we get our shell, we do a quick who am I. The next thing we see, which is interesting, is we're actually an admin. This surprises you, right? Instant lateral movement as an admin. But this is actually the default as AWS configure it. So by default, the SSM user that they provision is either a member of the administrators group on Windows or has sudo privileges on Linux operating systems. You can, and they do recommend that you remove these permissions or lower them if it's not suitable in your environment. We've never seen people do that. The next thing that happens is we use this technique against a domain controller. So again, domain controllers are EC2s too. We use the same technique, lateral movement, and we're a member of the administrators group. What do we know about the administrators group in a domain context? We're also a member of the domain admins. Now, this is really interesting because actually the AWS documentation says this shouldn't happen. They go out of their way to stop SSM user being present on domain controller hosts. So in this scenario that we've seen this happen, our assumption is that the client has manually re-added it onto that user onto the domain controller and maybe even manually made it a member of the domain admins group. So if you get into that situation, you're quite lucky. But yeah, that can go from a single AWS command to a domain admin perspective in the domain. And that's just the attack path here. So it's just kind of primitive that we quite often use. You can either use it to run a single command, run an implant, accomplish your objectives, or in a domain context, you might even get an identity that is really privileged within the domain. We're now going to look at another technique, the final technique we'll look at that uses AWS privileges. And this one, we're also going to look at kind of moving onto a host within AWS. So we're going to assume, again, we find a privileged IAM role that has a lot of permissions to a lot of objects that it shouldn't do. But in this scenario, let's say, just for the sake of it, the blue team's hardened the environment. So they've cut off the previous attack vectors we used, right? So we can't do SSM sessions, and we can't dump the disks of virtual machines. So what we can actually do to get a foothold on these virtual machines again is to not target the virtual machines themselves, but the networks they live on. So to do this, we're going to abuse a feature in AWS called traffic mirroring. This is effectively an AWS native way of capturing traffics out of cloud networks. It's a little bit convoluted, so what you have to do is set a receiver EC2 and effectively forward traffic dynamically from your target to your EC2 under your control. It's also only applicable to certain types of EC2s, but it's not a very major constraint. But effectively, you get a live packet capturing session from a target machine of your choice. There's a tool from Rhino Security that automates this, or you can just do it in the console with a couple of clicks. Now, if you use this to target, let's say, high-value targets in a domain context, you get a peak up of traffic. And one of the things we can look at in domain traffic is stuff like SMB with insecure challenge response-based authentication. The interesting thing about this is that what we can do is actually extract the challenge response almost as if we did a coercion attack ourselves, put it into a hash crackable format, the template of which you can see there by extracting the relevant fields out of Wireshark, pass it to Hashcat, and if you capture enough traffic of enough privileged hosts that have weak passwords, crack the credentials. So again, we've not targeted the virtual machine, we've gone after the network itself. And then you can use any lateral movement opportunity of your choice that takes a plain text password or whatever. In here, we just use simple in-packet scripts. But you leverage that password and you can get back into the domain context. So again, this is like nothing new, right? So challenge response, weak credentials, packet capturing, weak passwords, access to a domain. But the interesting thing about this is that if you were to do this against an on-premise environment or Active Directory environment, you might have to go out of your way to do it. So you might have to go and do something like compromise a router or switch. So you might have to jump onto a management network, find some credentials to these devices, or even come up with a 0-day or end day against a router or operating system. In AWS, it's a click away. You just click some buttons and you're capturing live traffic of other machines in the same account.
I like that technique. That's my favorite one. How are we feeling so far? 4 paths, 1 way? All right, got 2 more paths for you. 2 more, bear with me. Now let's look at some paths going the other way around, like James said. So first one is, we call them, let's say this one goes through the identity provider, right? So this path was actually possible after a Citrix breakout. So we had some domain users. All the domain users in that environment were given access to a Citrix platform. And in that platform, there were many apps. Most of them were vulnerable to breakouts. And the underlying hosts were not EC2 instances, so no quick wins there. We didn't have the identity yet. So obviously the goal is also, before I talk about the goal, from our reconnaissance, let's also assume that we see some users being AWS administrators from the domain. So we kind of suspect there's some synchronization going on and there's an identity provider. And let's make it more specific. Let's say that the AWS login and the access is regulated by Okta. So our goal is, how do we get into AWS and ideally get AWS admin? So this particular path requires you to first elevate your privileges locally. I mean, that's something you'll have to bring. That's a method you'll have to bring yourself. This isn't necessarily relevant. Pick your favorite one. There was a talk the other day that mentioned that statistically, from what BHE, Bloodhound Enterprise people see, there's always a privilege escalation vector. So we'll use that very helpful assumption. So let's say that you found a method and somehow you manage to move laterally to another host and you can get there landing in a privileged context. Again, the actual method for the lateral movement and the privilege escalation isn't relevant here. So you repeat that as necessary with your credential shuffle, dumping credentials, using them, and so on and so on. But if you manage to do that, then we argue that you should move towards the host that does the synchronization of the identity provider, the IDP sync host. In Okta, specifically, this could be the Okta AD agent. Now, you might be wondering why. Why are you recommending you to go after that host? We'll see in a second. For the curious, in our case, the actual privilege escalation was achieved by a combination of NTLM relaying, once again, and coercion of the web app service to perform RBCD, resource-based constraint delegation. We saw some engineers using Seatbelt that were logging into that host, that Citrix host. So we went after their hashes because we knew that they would probably have some more privileges. And once they had their hashes, we proceeded to move to that Okta host that we mentioned previously. Remember, that host is the host that does the cloud syncing. So it needs to be able to modify Okta entities. That means that it keeps some credentials locally. It's usually an API token. And in Okta's case, depending on what agent you've compromised, that token can be stored in two different ways. You can target the Active Directory agent, the Okta AD agent, where the token is a DP API protected secret stored in an XML config. And shout out to Adam for his research on that. That instructs us on what service account hash we need to find to eventually be able to decrypt that and get that SSWS token. That's Okta terminology. Effectively, that's the Okta token. Or you can target the Radius agent and simply AES decrypt the token with just 7 lines of Python code, no hash needed. And that's something we discovered with some basic reverse engineering of that agent, work done by our colleague Alexi. So once you have that token, regardless of which agent you targeted, it's technically game over. So you can set that in your Okta API request, contact the Okta API, and make yourself a super admin. A super admin in Okta, we'll see in a second what privileges does it have. But if you're doubting whether we're going to have the necessary privileges, it will most likely have the necessary privileges. That token you'll find will be able to make changes in Okta land. So you've made yourself a super admin. That means next time you log into Okta, you'll find that nice button over there on the top right, which gives you access to the admin panel. And on that panel, you can add your user into any group you want, any Okta group you want. And Okta groups is what organizations use to regulate access to AWS. So it's literally just a matter of finding the right group that grants you the desired permissions in the desired account. For example, it could be admin access into the account you're after, or an equivalent role, an equivalent IAM role. And here's a pro tip. There's one particular account within an AWS organization that can lead to access to all the other accounts. That's the management account. So I took some time to dig into the Okta documentation, looking into what's the recommended way to migrate multi-account environments into Okta. And they say that you should be doing that with Okta groups. You should be using Okta groups to map Okta users, like your users, to specific roles in specific accounts. So keep an eye out for any groups that look a bit like that, management admin access, because this effectively is going to give you admin access into the management account and allow you to own the entire AWS estate. Not just one account, all the accounts. That's the equivalent of enterprise admin. So to summarize, in this path, we saw how by using traditional domain-based period escalation and lateral movement techniques to compromise the identity provider sync box, one can compromise the entire cloud identity plane and eventually own the AWS tenant and all the resources within. And maybe even get lucky and own the entire AWS organization. Who knows? Cool. Last one is quite similar. So we previously talked about Okta groups. Now we're going to change it ever so slightly to go through standard AD groups. I mean, this is a very, very simple path. It's mostly here for completeness. This time we'll assume that you already have that domain admin foothold. You've compromised the on-prem identity and you want to pivot to the cloud, right? You want to compromise AWS as well. How do you do that? So in the more mature client environments that we've seen, there's a lot of automation going on. And cloud permissions end up being regulated by AD groups, by Active Directory groups. So it's a very simple task for the help desk admin, for the admin to just add someone to a group, and then they'll inherit the necessary permissions with Okta or with whatever identity provider is behind the scenes. You don't really need to care about all of that. You don't need to care about the identity provider. All you know is that there's this syncing going on. So you can simply enumerate the Active Directory groups, looking for ones looking like that, looking like a bit cloud related. Then just join it and wait. So yeah, lead tradecraft, I know. So if we guessed that right, if that group was indeed one that was synced by whatever identity provider is behind the scenes, next time you visit your IDP portal, your Okta portal, you'll see the new AWS accounts accessible. Magic. And that was our last path, ridiculously simple one, just to showcase another path, which is enabled by this cross-section of these two identity planes. And it's one that we've seen and exploited in assessments.
All right, so now we've looked at the individual attack paths, but what do they have in common and what are the kind of themes that we are looking at between them? So if we look at the AWS permissions to kind of see what are the services that we're kind of touching the most and exploiting during these engagements, it's stuff like IAM, EC2, SSM, as you saw. So these are the ones that are very closely related to concepts like identity, concepts of the actual virtual machines on which the Active Directory hosts are running. So that kind of logically tracks, right, with our assumptions that those are the services that AD interacts with, and therefore those are the services that we as attackers target. But there's effectively a brief summary of some of the techniques we've used most commonly and the kind of ways in which we've used them. Those aren't the only techniques we've used. So we've only shown a subset of the techniques we've used. There are a few other ways in AWS of, for example, getting code execution on virtual machines using user data. There's a bunch of things which integrate a bit more with Windows, allowing you to retrieve passwords. But a theme we see a lot, again, is just credentials being left everywhere. So in cloud storage, parameter stores, on the hard drives of EC2s themselves, that's quite a common theme in terms of kind of how we move around these hybrid Active Directory and AWS environments as well. But to kind of look at the broader picture, we want to kind of look at it like this. So in the old days, you have a traditional Active Directory control plane or network. So you've got some users, some computers, a domain and a domain controller. And then over the years, as Active Directory tradecraft kind of developed, attackers started finding attack paths through this. So now I can go from a low privilege point of view, do some lateral movement in PrivEsc, and take over the domain. But as the offensive side developed, hopefully the defenders were keeping up as well. They're paying attention to these techniques and they're looking at how they can restrict them in their environment. And so they're able, ideally, to cut down on these attack paths. They're able to actually kind of cut off the entire attack path all the way from low priv to high priv. Maybe they use things like tiering, the kind of hardening steps that we've been discussing at this conference. And it's much harder for attackers to find a simple, straightforward link from low privilege to high privilege. But then in these environments that we looked at, what people do is they take this Active Directory control plane and you pop it on top of AWS. And you can kind of see how the concepts in AWS align with those in Active Directory. So again, you have that other plane of users, you have IAM principles, you have EC2s, which host the actual computers in AD. And if we're an attacker and we look at this and we know the techniques that we can use in both environments, and we see that they're sitting right next to each other, then we can look at attack paths that look more like this. So we do a bit of lateral movement and a bit of privask in each plane, but we hop between them using the links such as instance profiles on virtual machines or the AWS commands that allow us code execution back into an Active Directory context. Now, this is quite interesting because it's quite analogous to the idea of the local and global kind of subgraphs of attack paths that have been kind of discussed yesterday. So you can think of Active Directory and AWS both as individual local graphs of attack paths and identities, and the links between them as the signs of the overarching global graph that links all attack possibilities. So this is kind of why we think these attack paths are seen, because these identity planes overlap, they have these links between them, and if we look at both at the same time, we can find nice attack paths that get us all the way from the start point to our objective again.
That's my favorite slide. If there's just one thought that I want you to remember leaving this room, that's the one. These two coexisting identity planes. But moving on to defenses, let's look at how we can prevent all of that. First we're going to look at some preventions, and then I'm going to hand it over to James for some detections. So if you're considering this topology, if you're the architect and you haven't implemented it yet, the evidence in this presentation would probably be enough to steer you away from that. Lifting and shifting domain controllers into EC2s is not a great idea. And that's something that the UK National Cybersecurity Centre, the NCSC, has also pointed out. It is, nevertheless, we have to recognize one of the migration scenarios that AWS themselves describe. They don't necessarily recommend it, but they do cover it in the relevant documentation and the relevant partner guidance. But the other two ones, so we said they have 3 scenarios. The other 2 ones, they recommend them more strongly. So you can use the managed AD service. They do actually have a managed Active Directory service by AWS, and that does all the heavy lifting for you. It does the scaling, the patching, the maintenance, administration, all offloaded to the cloud provider. Or you can extend your existing on-prem identity using AWS services like Route 53 for DNS or Direct Connect VPN lines. And they also give you some code, some CloudFormation templates to automate the setup for both of these 2 scenarios. Or, of course, you might be better off going for Azure altogether, completely different cloud provider. Azure avoids many of these issues, which we've covered, by bringing its own cloud identity plane, Entra ID. And with regards to DCs, lifted and shifted into Azure VMs, we've actually seen it once. We've seen that scenario as well, but it's definitely not common. We don't believe that to be a very common deployment scenario. And it's also worth mentioning that this particular solution, Azure and Entra, simply doesn't have that concept of role assumption. Role chaining simply doesn't exist. So it's one less TTP for you to worry about. Now, if that ship has sailed, if you've already implemented that, well, of course, you can address all the individual conditions. You can treat the symptoms. We've talked about all the different conditions that are enabled us to get there. You can harden your AD to prevent those. You can harden your AWS individually, but you know all of that. You know that already. That's not what we're here to say. You've probably had these flagged in your pen tests already. Quite commonplace. We won't focus on that. Instead, we believe you need to reconsider your entire threat model. Strong take. See, the root cause of all of these issues, like James mentioned, is the misalignment of the trust zones across these 2 planes. Now, you might have implemented your tiering on the AD side of things, but these security boundaries don't necessarily map to your cloud estate, allowing these paths, these vertical paths, to cross between the trust zones. So our thesis is that you should rethink your cloud security architecture, conscious of these paths. And that means, first, that cloud workloads should be segregated. That has been the key recommendation we've given in these assessments. Effectively, you should be treating the AWS account as the security boundary. For example, your DC instances, your domain controllers, have absolutely no reason to be in the same AWS account as your Citrix hosts. Don't do that. Not a great idea. Similarly, all the Okta EC2s, the ones hosting the agents, have no reason to be in the same AWS account as, for example, the CI/CD host, like Jenkins hosts, running all the automation, because all the pipelines. We all know these are full of secrets. It's a treasure trove for attackers, so keep them separate. keep these workloads separate. And secondly, your focus should be on identifying these paths that cross these boundaries. Exactly like you've been monitoring AD attack paths with Bloodhound, do the same thing in the cloud. It's not that you should be rejecting that altogether. Just do the same thing on the cloud using your favorite graph tool. It could be IamGraph. It could be ApeMan. Up to you. For example, you can start auditing periodically all the capabilities for cross-account role assumption, which is one of the TTPs that we discussed previously. And from a people perspective, we believe that bringing together experts from both of these realms is basically the only way to address these issues, right? Now, red teams do that already. I mean, we, for example, bring in AWS skill sets in APMs, same for our red team exercises. So there's no reason why the blue teams shouldn't be doing the same, both in the design stage and when implementing changes or security controls. Bring in people from both realms.
All right, and now in terms of what you can do to kind of potentially detect attacks like this. So to start off with, make sure you're doing your proper endpoint detections and AD detections. Not much point focusing on the cloud side of things if you can't detect fairly basic lateral movement and exploitation in the AD side of stuff. So hopefully you're doing all of that, although, it varies. But what can you do about AWS? So AWS is a little harder to monitor for, perhaps. Everything's an API. So there's less signaturable techniques to identify, and it's more about behavioral analysis. And in terms of behavioral analysis, one strategy is effectively picking some fairly high fidelity attacker actions. We'll show these here. So we've shown some of them in the attack paths previously, and looking at the context in which they occur. So IAM role assumption, right? Perfectly legitimate use case, but is it being performed by two roles which have never performed role assumption before? That's unusual. Maybe you want to monitor that. Similarly, SSM sessions, are they legitimately used by your administrators? If they're not, then someone opening an SSM session on a domain controller, probably very odd, and you're going to want to know about it. So these are the kind of techniques that we'd suggest as kind of a starting point for high fidelity actions. You want to look at how often these occur in your environment, who's doing them, baseline that activity, and then look for anomalies in this. But in terms of something else you can do to improve detection in AWS, improve the amount of context you have. So how do you provide the context for what's normal or what's severe? So a recommendation we really often make is have your engineers actually communicate with your detection engineers and your analysts to communicate what the actual critical principles and roles are. So say this role actually has admin privileges. We really want to know if it starts acting up. Or this group of users is highly privileged. We would like to know if someone adds themselves to it. You'll know that in a domain context, right? Your SOC analyst should hopefully know what the domain admins group is, but you might have defined your own equivalent of the domain admins group in a cloud context. So make sure you communicate what these critical roles and critical resources are to your detection team. And the next thing is to look at the techniques which especially cross between planes. So what implications do these have in a detection context? So if we take a kind of sample fictitious attack path, let's say that I compromise an on-prem user and that user has an Okta role. So I log into Okta, I get a role in AWS. Then with that role, I'm going to perform a simple SSM start session command against an EC2. And then within that interactive session, I might start typing some commands again to facilitate my objectives on the EC2. If we look at this, we can see that the telemetry is actually coming from 3 different sources here. So a simple, fairly straightforward attack path suddenly begins to get a bit more complicated in terms of how you can detect it because we're crossing these different planes. So think about how you can marry these sources together. So for example, here we've highlighted the actual host name of the virtual machine and the EC2 name. So these might be the same, these might be similar, they might be completely different. Have a think about in your environment, could you join these up in your alerts and your threat hunting if you had to? And the same for identities. So can you quickly and easily map from the identity which originally accessed Okta to the role which appears in AWS and performs actions? Because if you can't, then you're going to have difficulty when looking to detect activities which begin to cross between these different control planes. And yeah, that's our final thoughts.
Yeah, that's about it for today. Before we go, just some final shout outs to Sharon and TTM for helping us out with creating this presentation, Crispy for convincing us to submit in first place, Alexi for reversing the Okta decryption. You can find his tool IamGraph on GitHub, and Matt Lucas for passing the APM torch to us. On behalf of both of us, thank you very much for your time.
Do we have any?
We've got some references there if you want to take a quick picture.
Yeah, sorry if this is not super relevant to the talk, but I was interested in your attack path assessment methodology. Are these more like pen tests? Are you actively exploiting these paths, or are you just reviewing configuration? Oh, okay.
Yeah, so we will ask for like a read-only role to effectively speed up reconnaissance. So again, yeah, maybe some people might call it like an open scope pen test with, again, no aim at being covert. We also kind of aim to hold interviews with the relevant stakeholders we'll literally ask them, what are the high privilege roles from your point of view, instead of spending a bunch of days trawling through reconnaissance output, although we do that ourselves. But yeah, they are hands-on keyboard engagements.
Yeah, thank you.
So how do you determine which server has the OctaSync agent?
A few different ways. First one is the host name. We literally enumerate the domain, see them. Most of the times it's literally called OctaSync or Octa agent, like it sticks out. Otherwise, like James said, we will ask for read-only access to the portals, to AWS, to Entra if that's in place. Just speeds up the whole thing instead of someone going blindly and trying to figure it out all themselves. So we can see it there as well, confirm our assumptions. Is there any particular traffic coming out of that could potentially identify it? I believe it's quite straightforward to identify that host, though, even if you take a completely passive approach and start listening and see what.
Ideally, it's quite a privileged host, but yeah, if you look through computers, you can tell, oh, it has this label on it, or description in LDAP, for example. Yeah. The other thing that's maybe a bit more talks to the cloud side is that in the cloud, you can have tags on resources. And we've sometimes seen that be quite useful. So how do you know what this EC2 does? Oh, because they put a tag on the EC2 saying domain controller 01 prod. So that's another kind of giveaway or recon technique you can use.
There's a lot of things you can infer from EC2 tags.
All right. If there's nothing else, then thank you very much for your time. Have a nice day.
All right, thank you, James and Leo.